Good morning, everyone. Okay, good morning, everyone. My name's Mark. I'm from Technique Learning. I'm going to take you through a bit of a training session today on some of the commands that we use in PLCs. The two particular sections of commands that we're going to look at are the BCD functions of converting BCD to binary, etc., etc. And we're also going to take a look at the maths functions that are available and how to use them in some simple programs. The way this session is going to work is I'm not going to bombard you with lots and lots of PowerPoint slides and just reading through, but what I'm actually going to do is I'm going to use a little bit of the whiteboard behind me and explain some bits. We will go through some slides as well, and I'll also be creating some programs as we go through, just to show you some example programs of what we're actually talking about. But yes, this should take around about an hour, and hopefully you will gain a good insight into these commands and a little bit about PLCs. This is actually part of our larger suite of courses that we run, but this is just to give somebody something to do. So if you just bear with me, I will share my screen and we'll make a start on it. Okay, as I said, my name's Mark. At any point during here, if you've got any questions, you're more than welcome to type them down the side, and hopefully I will try and answer them during the session as well as we're going through if there's anything that I'm actually missing. But we'll start off with how PLCs actually function and what we need to do to get them to work right. Just bear with me 1 second. There we go. Okay, so PLCs, to control any application, it needs to receive signals from outside devices. So these signals that we're going to receive will be coming from all sorts of different things, but we're interested in the moment at looking at BCD. Now, a PLC itself can only understand binary information, but we might want to send that information to it in various other types of scenarios. So what we have is just a typical example here. This is a thumb wheel setup. So a BCD thumb wheel, which will then send a series of decimal numbers to the PLC, which we then need to read and interpret as binary coded decimal as we're using it. So the binary coded decimal system provides a means of converting the number used by humans in a decimal to a number that can be understood by the controller. So the number that's sent down from the BCD thumb wheel, we need to be able to interpret that and do whatever we need to do from the PLC. So how does BCD actually work? Well, BCD uses 4 bits of information to represent each decimal digit. So let's have a quick freshen up on actually how BCD works for anybody who doesn't understand it or hasn't looked at it since the school days. But the binary equivalent of numbers from 0 to 9. So each of them 4 bits represents a digit that can be from 0 to 9. So if we look at the decimal number 1, that would look as a system on a binary number as 0001, which gives a binary weighting of 1. Which probably then, if we were to look at some larger numbers, is probably easier for me to explain via via the actual screen itself. So what I will do is I will explain a little bit of this by using the whiteboard behind me and explain exactly how a binary numbering system could actually work for us. So if we look at a normal binary numbering pattern, it will work along the lines of that. So there's the first 4 bits. So we've got the value of 1, 2, 4 and 8. If we were then to carry on moving along, we go 16, 32, 64, 128. Now that's an 8-bit pattern. We could actually go further than that to a 16-bit pattern where the last number would be 32,768. But for our short example, what we're going to do is use this as 2 4-bit patterns. And a 4-bit pattern is actually also called a tetrad for anybody who needs to know that. So let's take a random number. Let's take the number, I don't know, let's take the number 99. So the number 99, if we were to write that as a binary pattern, would be 64 plus 32, which gives us 96, plus 2 plus 1. So the binary number of 99 is that. Okay? Now, if we were to look at this in BCD, we need to now split this down into 2 patterns of 9 and 9. So what we do is, instead of using this numbering system, we're now going to use the numbering system of 1, 2, 4, 8. So that's the first digit, and then the second digit is 1, 2, 4, 8, etc., etc. 1, 2, 4, 8, 1, 2, 4, 8. So the actual BCD pattern for 99 is 8 plus 1. So that gives us the first digit of 9. The second digit of 9 is going to be the same, which is 8 plus 1, which gives us that pattern, which, as you can see, is totally different to the decimal pattern. So this is the BCD pattern, and this is the decimal pattern. Now, the problem that we have is if we're going to send down, for example, this pattern into the PLC, so it reads it as a BCD value, but the PLC is reading it as decimal, then the PLC is actually going to see a completely different figure. The figure that the PLC is going to see is 128 plus 16 plus 8 plus 1, which gives us what? 128, 138, 144, 152, 153. So it's a totally different number that the PLC will actually see. So therefore, at this stage, this is where we now need to look at using some methods of being able to convert from decimal to BCD and BCD to decimal and interpret it within the PLC, whichever way we need to. Now, we're going to use the BCD Thumbwheel, as I explained earlier, as our little example. So if you just bear with me 1 second, I will put us back on. I will put us back on to the slideshow 1 second. So we're going to use the Thumbwheel. It's just one example of a device that could be used. The Thumbwheel has 4 output connections and a common output. Each of the 4 connections, the first, second, 4th and 8th, represent a binary weighing of that number, and they are individually wired so to the PLC input. So for number 7, the PLC represents it as 0, 1, 1, 1, which is 1 plus 2 plus 4. So if we're going to send that signal into the PLC, we would then now need to do something with that. So how are we going to actually do that? Well, the easiest way for us to do that is to use what is called the Frd instruction. The Frd instruction is from Bcd. That is the actual title of it, and that means basically we're going to convert the value that comes in from Bcd into its binary equivalent. So a decimal number is sent to the PLC as a Bcd equivalent, and then the PLC software would then need to use the instruction to convert that to a binary value, which it's going to do using the Frd instruction. Now, the Frd instruction, as we'll see when we put it into a short program in a second, can either be something that's totally continuous, i.e. unconditional, or it can have a condition before it that would allow you to only do the conversion as and when you tell it. So looking on this example that we have on the screen in front of us now, we have the Bcd there of 18, which is 8 at the beginning and then a 1 in the second digit. So then we need then to that reads that as a binary number. Now the binary number of that would be 1, 2, 4, 8, 16. So it's actually 16 plus 8, which gives us the number of 24. So we need this instruction, which is the Frd instruction, to actually convert that to give us the value of 18 within the PLC. So in this particular example that we have here, this is where we're going to use the Frd instruction and actually put a little program in that hopefully may explain it a little bit better. So just bear with me 1 second while I swap my screen over to something else. So I'm going to stop sharing this screen so you're back to myself, and then I'm going to share you on. So what I have here is a little simulator. This simulator is actually very much like the Alan Bradley software. This is a simulator for the RS Logic software. Here at this side of the screen we have the simulation package. Here is where we're actually going to write the program. So at the moment all I'm going to do is put something very, very simple in there, which is going to be a new rung of code, just one rung of code, that's going to allow me to, in 1 second, going to allow me to put in the Frd instruction. So the Frd instruction, as we move down, you can see all on in the compute maths you have the Frd instruction, which is from Bcd. We're going to take this Bcd input simulator here, which is input 5, which is a word. That is a word of data because there's 16 bits in there, and we're going to take the input of that, which is going to be I:5, and we're going to put it into an example of a timer preset. So what we're saying here within this program is take the value from this word here, which we can increase or decrease, and put it into the preset of a timer. So let's drop a timer on the screen so we can actually see it doing something. So we'll create another rung on there, and we'll use something as simple as an input. So we'll use I:. Now our inputs here are on I:1, as you can see up here. So we'll use I:1 /0, which is the first input to start a timer. And our timer that we're going to use is going to be T4:0. So that's going to be the timer address that we're going to give this particular PLC. At the moment we'll give it no preset, because the preset is going to come from here. And what we need to do is just press this button and hold the timer on. So we're going to create a latch around the input to hold the timer on. And we'll do that by just using the timer timing bit. So as the timer first energizes, it will create a latch which will hold itself on. So once we've done that, we can download that to the PLC and we can go online. We can turn the PLC into run. At the moment, as you can see here, we have no preset in the timer. As I move through the Bcd Thumbwheel, you can see now I'll give it the value of 1. So 1 has now moved to the timer. If I move the second digit of the thumbwheel, it now has a value of 11. So let's just trigger that by pressing the button, and you can see the timer there running for 1.1 seconds, because it's 11 times 0.1 second time base increments. So once again, so what's happening at the moment is it's taking this value and it's converting it. As you can see, the value that's actually coming in is 49, because we've got 1, 2, 4, 8, 16, 32. So it's actually 32 plus 16 plus 1, which is 49. It's then being converted within this Frd instruction to the binary equivalent of the BCD value of 31, and outputting that into the preset, which we're then using here to create this wonderful timer. So as you can see, I can now increase, decrease, and do whatever I want to do there with this thumb wheel. Okay, so bear with me 1 second while I drop us onto stop sharing. Okay, you're back with myself. So that's just a very, very short program about using the Frd instruction. We're going to use that in a little bit more advanced in a short while with another instruction, because all we've done at the moment is gone from BCD to binary. We also then need to come back the other way, which is going from a binary pattern into a BCD pattern. So how are we going to do that? Just first of all, I'll once again share my desktop. So we can skip through that one. We're now on to the next one. So that's how we've actually done it. That's just giving you a graphic of the representation of what we've actually done. So the next thing we need to do is now start to look at the Tod instruction. The Tod instruction actually stands for to BCD. So we're now converting from binary to a BCD pattern. So the PLC sends out a BCD number equivalent to the binary number, and it gets displayed as a decimal number on the LED display that we're going to use on our simulator. The Tod instruction is used to convert the binary value of a decimal number to its equivalent BCD value and place the results in the destination. So the Tod can be named as binary to BCD conversion. That's basically what this instruction does. So what we have here on the screen now is this is where we're now outputting to a BCD display. So we're taking the value which is coming in and we're putting it into a BCD output pattern through here, which is then going to be displayed on here. So we're going to use output card 6. The reason we're going to use output card 6 is because output card 6 is what is on the simulator for us to use. The instruction itself has two parameters. It has a source and a destination. What we're going to do is take the timer timing. We're actually going to look at the time of it, and we're going to put it into output card 6. And that will then take the binary value, convert it to BCD, and output is a BCD pattern, which hopefully then we will be able to see on the screen as a working pattern. So what we have is we now have two commands that we're going to use, which is the Tod, which we've just looked at, and the Frd, which we looked at earlier. So we're sending and receiving information. So let's take that now and create a short program using the software with that as well. So let's share that particular program. Okay, so we're now going to create a little program that we've got there. I'm going to delete this and use a new program. Now, to be able to do any deletion or anything within this, we need to take it offline. So we're going to go offline with the actual processor itself, and then we'll delete the rungs and start from afresh. So what we're going to do now is we're going to use a couple of timers. So first of all, I'll add some rungs into here for us to use, and we're going to use the Frd instruction on the end of this rung, and then we'll create a branch around it, and we're actually going to use two Frd instructions because we're going to have two timers within this particular program, so we need to convert two of the presets. So within here we're going to take I:5 again, and we're going to put it to the first timer, which is T4:0, and it's .pre. We're taking it to the preset of that, and then once again here we're going to take I:5 again, and this time we're going to put it to another timer, which is timer 1. So we're now converting whatever comes in on input card 5 here and taking it to two presets. Then we'll create ourselves just a very small basic program to see this running. So what we'll have is something along the lines of when we press the first input, I:1, we'll start a timer, and that can be timer T40, which is already pre-populated for me. It's got the value of 32 in at the moment, that'll be fine. We'll then create another rung, not there, we want to put it underneath ideally to keep it nice and neat, although as I'm sure you're aware it will make no difference to the program. This is just for a neatness issue. So we're going to now say when the first timer is done, we want to start the second timer, which is going to be T41. Again, we don't need to put a preset in because that's going to be pre-populated by that. But what we want to do is just say that when the second timer is done, the first timer runs again. So we're going to put T41 not being done allows that to run. Okay, and then we really need a rung to convert that as a TOD. So we're going to put the TOD rung in now. The TOD rung can be completely unconditional. There's no reason to have anything in there. And we're going to take the accumulated time of the first timer, for example. So that's the .acc. So that's looking at this portion of the timer here. And we're going to output that to output card 6, which is this BCD output display here. Okay, and just for some indication, at the same time we'll have a small indicator on here that just says while the timer's timing, let's just put a light on. So we'll use the first timer again. So while T40 is timing, put me on, we'll just put this light on here. So we'll take that light and we'll put that on there. Okay, so let's see whether we're working. Hopefully we've got a program that's going to function. So now we need to go online, put it into run. Okay, so as you can see there, the preset, you can see the display is counting up to 32. So let's just change this to a bigger value. So I've given it the value of 126 for argument's sake. I press my finger on the button, and you can see on the BCD display now it's counting up, and it will count up to 126. But what you should also be seeing is that output 20 is on while it's doing that as well. So that's just an example of a FRD and a Tod command being used. So just to summarize before we move on to the maths instructions, what we have now on here is we're converting here from BCD to decimal and put it into the preset of these two timers. So they now both have the same preset. I've created a flip-flop timer scenario here that we can see on working on the display, and we're outputting the accumulated value. So as that timer runs up here, it's being outputted by converting it from decimal to a BCD code on output card 6 here. So when we press the button, you can see the value is being run there. And hopefully that's given you a little insight into how the actual BCD system works and how we can use it within an application to create a program that works using a BCD Thumbwheel and maybe a BCD output. So we're inputting a number which the operator can put onto the display, and we're outputting onto a BCD display as well. It's just a very basic function that we may want to use within our program. Okay, so hopefully that's given you an insight. We're now going to move on to some basic maths instructions. Basic maths instructions are very commonly used within a PLC. Again, I'm going to share my screen with you. Very commonly used within PLCs, and most maths instructions are very simple to use. So you've got things like add, subtract, multiply, divide, tangents, cosines. Instructions like that, they're all application dependent. You would use them as and when you have a requirement to them. They are block instructions, and they generally always have two sources and one destination, because let's take this as an example of an add instruction. We want to add something to something and put the answer somewhere. So we have source A, which we're going to add to source B, and we're going to put the answer in the destination. Math instructions are always output instructions, so we always add them to the right hand side of the rung, and they all work in the same way. Okay, so source A and source B are always read only, which means that it's just that we're going to take information from wherever, any registers that we might use, and then we're going to add them together in this particular example and put it into the destination. And the destination is not read-only, the destination is writable, because we're going to change that as and when we do the add instruction or the subtract instruction, or whichever instruction we happen to be looking at. So the types of maths instructions that are available and what we can put into them. For this particular example, what we could put into source A or source B can be anything along the lines of, it could be the rack location, so like we were using in the previous command, that's looking at the whole word itself. It could be a file address such as N7, which is basically, let's call it a pigeonhole where we can hold a value. It can be an instruction field, so it's coming from somewhere like the accumulated value of a timer or the accumulated value of a counter or something like that. And it can also be a constant, which is a fixed value, which is just basically a number that's going to sit in there and do the job that we want it to do. So The destination field that we can put in there can be, again, it could be an output location, so we could be outputting directly to an output card. We could output to a file address, such as N7:9, N7: whatever number you might be using, which again is a pigeonhole for us to hold that value to be able to then do whatever we want to do with that value. Or we could output to a counter preset, a timer preset, as we did in the previous program, or anything along that lines. So, operation of a maths instruction. A maths instruction is very important that it always happens every scan. So whenever we're using a program, the maths instruction will happen on each scan. Okay, so just bear with me 1 second while once again I bring you back to my screen. Let's look at how a timing chart works and what we're actually talking about here. I won't rub all this off, I'll just work at the bottom of the screen. What we've got is when something is switched off, it is a 0. When something's switched on, it's positive, it's a 1. And a measurement along the bottom of time. Okay, so if we've got a button switched off, it sits there in time, and then when it comes on, it triggers, it stays on while we've got the button energized, and it goes off like such. Now, the important parts to this here is this bit here first of all. That is called the rising edge. So that's when something is being triggered positive. This portion here is called the falling edge. So that is when something is going from positive to negative, as we call it, because this is negative, where actually it's at 0, and this is the positive. Now, why have I actually drawn this? The reason that I've actually brought this up and explained this to you is because a maths command works on the positive edge. What that means is, let's say, for example, this is a time of 1 second between here and here, and we press our button for 1 second, it's highly likely that the PLC will have scanned probably 50,000 times within that second. So therefore, the maths command will have added or subtracted, or whatever command you're using, 50,000 times, and we'll see a massive ramp up in the numbering system. So we need to take that into account, and that's not just Allen Bradley PLCs, that's all PLCs that always work on the positive edge. So what we need to do is look at something else on there. So once again, back to share my screen. So what I will do now is just very briefly draw you a small program again and explain the command that we may need that's going to stop this happening, and we'll see what actually happens as well if we don't put it in. So I'll just once again bring the simulator up. 1 second. Share my screen once again. So once again, I'll delete these rungs. It's just a quicker method than starting a new program. I don't need to keep these, so delete, 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 delete. We'll put a new rung in there. So let's just have an input. We'll use this input, so we'll put a normally open contact on there, and we'll have an input of 0, 0. So when I press this button, we're just going to use the maths command of add for now. So we'll use the add command here, and we'll add, let's say, N70, which is a pigeonhole, it's an integer, and we'll add on to it the value of 2. So every time we press it, it adds 2 to it, and it puts the answer back in N70. So we're going to put it back into its same place. So we're adding the pigeonhole N70, we're going to add 2 to it and put the answer there. So before we do anything else, let's see what happens. So let's download that to the PLC, and then let's go online into run. So now at the moment, as you can see, N70 has got a value of 0. So if I press this button, you see how it's added up very, very quickly just by me holding the button down. So the longer I hold the button down, the more it adds every single scan. At the moment, I've got this to scan 40 times per second. So that's adding 41, 42 times per second. If I really increase that up to a massive value of like 1,000, you can see that ramp up really quickly. I don't want to hold it too much. So let's take that back down to a reasonable value, something that we can see. Okay, so now you can see why there's a requirement for us to put a command in there to stop that happening. So I'll create another rung. So let's go back offline, and we'll drop another rung onto here. And we'll use another button. So this time we'll use the next button down, which is input 1. And we'll use the add command again, but this time we'll not use N70, we'll use N71, which is just a different pigeonhole we can use. And once again we'll add 2 to it and put the answer back in the same place. But now we're going to introduce a command into here that is going to allow us to stop that massive increase happening all the time. That command that we're going to use is called the OSR command, which stands for one-shot rising. That basically means for one scan only will it execute what's on the outside of here. Now a one-shot rising command requires an address, and the address needs to be an internal relay address, which is a B3 address. So I'm just going to give it the first B3 that is available. And what I'm also going to do is I'm now going to download that to the PLC. We'll go online again. We'll put it into run. But before I do anything, I'm going to open up the integer table for N7, which we do here. Drop that into decimal. You can see N70's got that massive value. I can just drop that back down to 0 so it's available to use again. So N7, the first button increases dramatically. Pressing the second button, doesn't matter how long I've got my finger on it and I've still have my finger on that button, it's only added 2. So only on each time it sees the rising edge does it do the add of 2. And that is pertinent for all mathematical commands. Yeah, it must have a one-shot rising being used within it, as otherwise you're going to get this very, very large increase in as it goes through. So hopefully that's given you a very brief explanation on why we use this command. We're actually going to come out of this now and back to myself for 1 second. So stop sharing, back to myself. And the next thing we're going to do is we're going to actually look now at a little sample program which is going to allow us to create a conversion using several maths commands. What we're actually going to do is look at converting from Celsius to Fahrenheit using the mathematical system that we can use. So first of all, once again I'll share my screen so you can see what the mathematical command actually is that you're going to need to use, or I'm going to use. So you can see there, to create conversion from Celsius to Fahrenheit, that is the equation that is needed to be able to do so. So how are we going to do this? What we're going to do is using a combination now of FRD commands and our mathematical commands. Hopefully we're going to create a program that's going to allow us to see all this happen on our screen. So once again, back out of here. Second. So I'm going to stop sharing that, and I'm going to once again reshare the the program that we need to work with. So now I'm going to create a program using the software again that hopefully is going to be a combination of all the different commands now. So I'm going to go offline once again, delete what I've created because I don't need to keep that, and I'm going to create myself probably I'm going to need probably about 5 rungs for this. 4, 5. So my first rung is I want to take the value from here and put it somewhere. So once again we're going to use that Frd command, because if you remember we're going from Bcd. So here we're taking the input card 5 and we're going to put the value that's that, and we're going to convert it and put it into an integer file, which is an N7 file. Then what we really need to do is, with that command that we looked at earlier, the first thing we want to do is take that N7, so take that number that we've coming from the Bcd Thumbwheel, and we're going to subtract 32 from it. And once we've done that, we're going to put the answer somewhere else. We don't want to put it back into the same file. So we're going to put it into N7:1. So we're taking the value that's in here, converting it to decimal. We're then taking that value, subtracting 32 from it and putting it in another pigeonhole. The next thing we want to do, again, with the equation, is we want to multiply. So we're going to take the N7:1, we're going to multiply it by 5, and again we need to put the answer somewhere else. So we're going to put it in N7:2. So we're taking what we've subtracted here, multiplying it by 5 and putting the answer in N7:2. And then what we need to do with that, notice this is all unconditional, so this is happening every single scan. So now we're going to take N7:2 and we're now going to divide it by 9, which is part of the equation, and we need to put the answer somewhere else. So we'll put that again into N7:3 this time. So we're taking it from here, converting it, we're then subtracting 32 from it, we're then multiplying the answer of that by 5, putting it in another integer file, we're then dividing that by 9, putting it in another integer file, and then the final thing we need to do is take that and convert it to a Bcd. So now we're going to take N7:3 and put it in the output file, which is output file 6. Okay, so what we're doing, just to explain this before we run it, is we're taking the number from here, we're taking it from Bcd, converting it to a decimal, we're then taking that decimal number, subtracting 32 from it, putting it in another integer file, we're taking that integer file, multiplying it by 5 and putting it in another integer file, which we then take that integer file, divide it by 9, put it in another integer file, which we then convert it to a Bcd and put it in the output. So hopefully we may get something that looks fairly relevant. So we've downloaded, we'll go online, we'll put it into run. So what we have now is, here's the value, and now that's being converted. You can see it running through the file and coming out the other end as the equivalent. So we're taking it from a Fahrenheit and putting it to Celsius. So we're doing the conversion within here, running it through these files to allow that to do that. So that's a fairly simple program to allow something like that to happen, and we're using a combination now of both the conversion commands that we looked at earlier, and now we're using some simple mathematical commands to allow us to create that program. And just to remind you why we've used subtract 32, multiply by 5 and divide by 9 is because that was where we got that. So we took the value, we subtracted 32 from it, we then multiplied it by 5 and then divided it by 9, which is where that actually came from. So hopefully that has given you a little bit of an insight. So just bear with me once again. Screen off. Back to myself. Hopefully that's given you a little bit of an insight into some of the commands that are used within PLC programming. All we've done there is just use two very simple commands. There has been an assumption that you already have a basic knowledge of PLC in being able to create timers, etc. within this program, but that's basically just a short introduction to the commands, and hopefully it's given you an insight. Should you require to take this any further, you've got any questions that you want to ask, then you're more than welcome now to drop them down the side of the screen, and I will answer them for the next few minutes of anything that you've got any queries about what we've talked about. This is, as I said earlier, is part of a larger suite of courses that we run, from very, very basic PLC programming up to quite advanced programming, using a variety of different PLCs from Allen Bradley, Siemens, Mitsubishi, OMRON, etc., taking you to a high level of programming should you require. As a thank you for watching this, what you will be receiving in a short while in your inbox is a discount voucher for any courses that you may want to book with us, that's going to give you 20% off the PLC courses. So as I said, any questions, I will be staying online for the next 10-15 minutes to answer any questions before I drop off. But once again, thank you for watching this little lesson, and stay safe out there. Enjoy yourselves, everybody. Thank you. There is a question, will the recording be shared at the end? Yes, there will be the option to be able to download this this particular webinar and replay it again, watch it at any point, which you're more than welcome to go on. You will receive a link for you to be able to do that. It will also be available on our website to download, which is learntechnique.com. You'll be able to go on there and download it directly off our webinar link. There are some other webinars on there as well that may be of interest to you that have been run previously. Yeah, in answer to Chris's question, we do classroom and online courses. Predominantly, historically, we've always done classroom-based courses over the years, which are running all the time. We have several. We actually have 4 or 5 PLC tutors, and we run them from a variety of different centres that we have around the UK, which are all available to see. We run from Chesterfield, Newcastle, Manchester, Watford, etc. We have centres around the UK where PLC courses are run from. We also now run a range of PLC online courses which aren't e-learning packages. They are dedicated where you would be sat with a tutor doing the course as though you were in a classroom. It's not just a PowerPoint presentation. It's very similar to what I showed you earlier, where we're actually using the board explaining stuff, and we would see the trainees on the screen using our classroom software, and you can ask questions as though you were sat in front of us. We use simulation software for that, obviously, which we provide, and you're given that as part of the course fee. It's free to you. You get it to keep forever to be able to play around with. Obviously, if you come into one of our centres, we have hundreds and hundreds of PLCs here that you can connect to. We also can come out onto site. We quite regularly go out onto customer site and run training courses on their sites with their equipment and bring some of our training rigs as well. So there's a massive amount of different options available for anybody, but the online courses are running fairly frequently. There's one running probably every 2-3 weeks at the moment. Hi Ian. Yeah, in answer to your question regarding the courses available, I'm not quite sure which bit of the website you're looking at, but from an Allen Bradley point of view, we run courses on RS Logix 5, RS Logix 500, Control Logix, RS Logix 5000. We run all the different packages, and we have all the hardware and software here to do so. We do it on Siemens S7 200s, which is Step 7 MicroWin. We use Step 7, we use TIA Portal. We use all the different packages which people have a need to use. Mitsubishi, we even sometimes get asked to do it on Medoc, but we use GXWorks, GX Developer, things along that lines. It's whatever package you desire, or a combination of them. If you were to come here and do a course that is over 2 weeks, you would use a variety. You may use Siemens and get to a decent level of programming a Siemens and to a decent level of programming an Allen Bradley within that period. Adrian, is there going to be any more free courses? There always will be. We drop them on now and again, and surely we'll mail you out when the free courses come. One of the next courses that we're going to be presenting very soon is a course on communications of PLCs, looking at PLCs, SCADA, the IoT, the Internet of Things, and how they all work together. That's going to be more of an overview course, and that will be coming up in the next week or so, once I've put all the presentation together to be able to present it as an online course. But yes, there will be free courses running all the time. Chris, is our courses accredited? Yes, they are. We are accredited we do PLC courses that are accredited by City and Guilds. We also do level 3 qualifications by EAL in PLC. So we run through a variety of awarding bodies, but actually for PLC and for SCADA, if you're interested in SCADA, we run under City and Guilds accreditation and under the EAL accreditation schemes. So yes, they're not, we don't just provide in-house certification, it's all proper accredited certificates. Dragos, in answer to your question, we have some our rigs that we use here when we're on our training courses are real life industrial rigs. So we have conveyor systems, pick and place systems, we have robotic measuring systems which we can swap over different PLCs in. We've invested very, very heavily in our PLC setup. So for example, our conveyor systems, you would be able to put a Siemens PLC in there and program it. You would then be able to take that out and put an Allen Bradley or a Mitsubishi. Different PLCs would be able to be dropped into our rigs. So we don't just use push buttons to simulate. We also try and use real life training rigs wherever possible. And we also give you true to life scenarios. As a programmer myself, I will show you some of the programs I've written over time and other sample programs that we have of real programs that are out there. So within the courses themselves, you get a good understanding of how it works in the real world. Okay, Robert, in answer to yours, this particular webinar is not really the most basic webinar we've done. It may be worth you going back onto our website and downloading a basic one. which will show you how a timer works and how you address that. The other option you would have, Robert, is either to do an online or a within our centres training course, which could be a week or 2 weeks, which would also give you the qualifications as well. And that assumes no knowledge. That the first course that we run that gets you with a qualification as well assumes you have no previous PLC knowledge. So you would start from very, very basic, and where I've gone through earlier about I've just dropped a timer on the screen, it would explain how that timer functions, why I addressed it as T4:0, what that all means, etc. So it may be worth you looking at one of our basic training courses as well, to get you to a level where you can go online and start programming, monitoring, fault finding and understanding PLCs to be able to use them as a tool in the real world. In answer to your question, Faison, I would suggest that you would do one of our level 3 qualifications with your level of electrical and electronic qualifications already to that standard. You would pick it up relatively easy, but it again would give you a very good grounding, and we don't stick by a syllabus. So if there are 6 people on a course, and one person is shining, we won't hold them back. They will get to a very high level within the course when they're in one of our training environments. So you could get to a very advanced level very quickly holding a master's in electronics engineering as you do. Yeah, we don't restrict people. We will take it to whatever level we can. The online courses, Chris, are usually, if you're going to do a fixed online course, they usually are 9:30 till 4:30, because it is exactly the same as we would run within a classroom environment. So you would be with the trainer from 9:30 to 4:30 for Monday to Friday if you were doing the week's course, exactly as you would be if you were coming to do a training course within one of our training centres. We don't particularly agree with e-learning. E-learning type courses give you a very basic understanding, but to actually get the full benefit of running a training course that's going to give you the information you need, it's when you get that interaction with a trainer like myself or one of the other trainers, that when you get stuck or you're slightly confused on a bit, we can point our webcams at the board as I was doing earlier and explain it and get it through to you, so you get the most from the course that you possibly can. So yes, generally they are 9:30 till 4 o'clock. We are going to run some of our free webinars out of working hours very shortly, because we have noticed people have been asking for 5 o'clock, 6 o'clock out of working hours type courses, so we're going to run them as well. But all our webinars that we do that are free are also freely downloadable at any time anyway. I would suggest, Faison, in answer to your question, that you would, if you could do the first week's course online, see, that can, again, we will take you to whatever level we can take you to within a week. The online course will take you to a fairly decent level. However, if you want to get to an advanced level of programming, then at some point you would require to come into one of our training centres, because what we can't really simulate is things like how to set up communications between Profibus, AZBus, things along that lines. That can't be done really as an online module. We can get you to a good level of programming, but really the last stage to get you to a very advanced level or a good advanced level would require you to come into our centre at some point. But you could certainly do the first sessions online and then see where that takes you, yes. In response to yours, yes, Chris, there is final assessments. The City and Guilds one is done at the end of the first week. So if you're doing a City and Guilds qualification, that would be done at the end of the week. If you're doing the level 3 EAL, that's done at the end of the second week. They aren't examinations, they are assessments. So one of the things that we believe is you can work as a group. So if you were doing it in one of our training centres, it's not that you would be sat in exam conditions doing it quietly. You would be encouraged to sit as a group of students and come up with the answer as you would do in the real world. In the real world, you would sit around a table and say, right, we need to write a program to get this conveyor system working correctly. How are we going to do that? And you would come up with that answer between you. We have an extremely high success rate because what happens is we take you to a far greater level of knowledge to be able to pass the assessments. So you would sit as a group, you would do it as a group, you know, you would be expected to do the lion's share of the programming yourself, but any bits that you need assistance with, you can work that between yourselves to bounce ideas off each other and come up with the appropriate answers. Can you be certified online? We can certify you, yes, online to City and Guilds. We can do a 1-week PLC training course online, which at the end of the week, we can certify you to City and Guilds standard. Yes, we can do that. The EAL level 3 qualification does really require you to come into the centre because it's taking you to, it really requires you to do it on our rigs as opposed to just doing it as a simulating software package. But yes, we can do that. We can certify to City and Guilds in our 1-week course. Okay, everyone. Well, questions seem to have stopped. What I will do is finally just put our email address on here for you to, if you've got any further questions, you can direct them directly to me. And I would more than be happy to answer any questions that you're having that are related to PLC. Oh, sorry, one last question. Faison's asked the course. To be perfectly honest, I'm one of the tutors. You will get an email very shortly, Faison, about the course costs, because at the moment, as I said, by you sitting on this course, you're subject to a 20% discount, but I'm not quite sure what the cost of the course is. I'm one of the PLC trainers. If you live 5 minutes away from our Manchester centre, Robert, then that'd be an excellent venue for you to do that course. It's running probably every 2 months at Manchester. We actually have a trainer who is based that way that works mainly from our head offices in Chesterfield, but he's actively wanting to run more courses from Manchester, obviously, because it's a lot closer to him. So yes, there is going to be lots of courses run from Manchester. So once again, I'll give you my email address, which I put onto the chat. You're more than welcome to give me any questions that you need. The final few questions that are still coming through. Which certification is better? The City and Guilds qualification is an awarding body that's got a very, very good reputation. It's got an extremely worldwide reputation of people knowing about City and Guilds. However, the EAL qualification is a level 3 qualification, which is a skilled level of qualification. I personally think a combination of both is the best, but to have a City and Guilds qualification in PLC programming is certainly worth having. It is a good qualification to have. Do we have any training centres in Birmingham or Stoke? At the minute, Faison, no. However, very soon we are looking at putting a new training centre that way on. We have a centre in Watford, which is probably, if you live south of Birmingham, is probably closer than coming to our Chesterfield centre. But at the moment we have nothing there, but we may have in the future, within the next few months. That is something that actually we, as a company, we've been looking at putting one down in that area. I'm glad you enjoyed it, Chris, and thank you everyone. I am going to sign off now. Go and grab myself a cup of tea. I hope you've all enjoyed it, and as I say, any questions, you're more than welcome to email me, and I hope to see you on another one of our courses very, very soon. Thank you.